Welcome. We're going to do part 2 of 4.2. We're looking at piecewise functions, which are subfunctions. So the general function is the sum of each of these subfunctions, and we're using point slope here for a lot of these expressions here. So first it says where x represents the time in minutes. So if I was to do a graph here, this would be in minutes. And it also says that the distance traveled is in kilometers, and that's the dependent variable. So this is distance, and the unit is kilometers here. All right, and they give you the piecewise function for these three different domains. These are the three different expressions. And the first thing they want to do is to say, well, what is the c value here? And one way to think about this is we know, based on point slope, that 2 times x minus 20 plus 30, since it's x minus x1 plus, that should be y1. Okay, we know that 20 and 30, 20 for minutes and 30, we know that there is a point there at 20, 30. So we also know that the 20 is part of the domain for this function that we're trying to solve. So if the input, if the x value is 20, the output, the y value is 30. So we can write an equation to solve for the value of c. So we're going to say 1/2, and instead of x, we're going to say 20, because that's the x value, minus 10, plus c, some variable, returns a value of 30. And so 1/2 of 10 is 5. And so therefore we can say that c is equal to 25. All right. Now, sketch the graph. Well, it's going to start at 0, 0. 1/4 x squared is from 0 to 10. So at the point where you have 10 minutes, you have 1/4 of 100, or 25. So there's going to be a point kind of over here, and it's got half of the parabola here. The other one has a slope of 1/2, and it's going to be something like that. And then the last one has a slope of 2. And this one, if you plug in 30 into this equation, you end up with 2 times 30 minus 20 plus 30. Well, 2 times 10 is 20, plus 30 is equal to 50. So at the 30 point, we would go up to 50. And it is a linear equation, point slope. So it would look something like that. What is the domain of h of x? Well, we can see it's limited here with these constraints, and the domain starts at 0 and it extends to 30. What is the range? Again, we can see it starts at 0 and it extends up to 50. This was at 30, 50, so it's going to go from 0 to 50. Whoops, that should be including that. And then which 5-minute interval has the greatest average rate of change? So if we look at the slopes, this one was 2, this one was 1/2. We know it's not going to be that middle one. Now the average rate of change here, we have a value at 10, 25. And so the change and we have a 0, 0, right? So the change in y is going to be represented as 25. The change in x is going to be 10. So this is actually going to be 2.5 as my average rate of change. So therefore, that's from 0 to 10. Now, actually, it's actually different, because they've split it up from 0 to 5 and 5 to 10. and they've done some others here. So what you would need to do here is you would need to plug in some values. So from 0 to 5 is going to go from 0 to 1/4 of 25, so 25 force. And then the next one is going to go from 25 force to 25. And then from 25, if it's a half, if we plug in 15, we get 5 halves plus the C value, which is 25. So it's 25 plus 5 halves, or 75 halves. And then we've got the 75 halves, and we go to 30, which is at 50. So we go from 75 halves to 50. So we've already eliminated some of these here. So anything in this 10 to 5 is out, right? 25 to 30, this was the one with the slope of 2, so it's a possibility. Now, because it's a parabola, the steepest part, on average this one wins, but the steepest part is going to be right here. And you could say it's 75 force, which is not that far from 3. So that's going to be the steepest.